In this lesson, we are going to look at algebra. Now, algebra is just a part of mathematics in which letters are used to represent numbers and quantities. So what we are saying is there is what we call an algebraic expression, which is a mathematical phrase that contains numbers. Sometimes it may contain operators such as we need to have addition, subtraction, multiplication and division, and at least there should be one letter. So okay, now here let's say if we have 2x, so from the statement there we can see that this number, the number 2, this number 2 is known as a coefficient. So we have a coefficient. Then our letter x is known as a variable. So any letter from the alphabetical can be used, and any letter is known as a variable. Then any number is known as a coefficient. Now from there, we need to also look at the like terms and unlike terms. So what are like terms, and also what do we mean when we say they are unlike terms? Okay, now the first thing that we need to have for an expression or expressions to qualify to be of like terms, number one, they should have same letters. So same letters. Then in the other point, they should be raised to the same power. So what this means is if I have x, another x, these two are like terms, or maybe 3x, negative 10x, all these are like terms because they all contains the variable x and they are all raised to the power 1. So you can see that each variable is raised to the power 1, so they qualify to be the same like terms. Now the other way, if maybe we have 3b squared, 15b squared, then 5, let's say, b squared. So even these they are like terms because we have the same variable b and they are all raised to the same power 2. So the first point that we need to have in mind is the like terms. For an expression to qualify to be a like term, they should consist of the same letters and also raised to the same power. Now, so in a case, if you see maybe if we have letter x raised to the power 1, then plus letter x raised to the power 2. Here we are dealing with these are like terms because even if they have the same variable, the powers are different. The powers are different. So for like terms to qualify to be like terms, we are expecting the first statement is there should be the same letters. Then the second statement is they need to have the same powers. Then the other thing that we have to know is like terms can be added. So can be added or subtracted. So what we are saying is if let's say we have 3b squared plus 5b squared, when you are adding, first you need to add the coefficient. So 3 plus 5, we get 8. Then we have the b squared. So after adding like terms, remember that the power of the variable does not change. Then in terms of subtracting, if we have 3b squared minus 5b squared, so we are going to use where we have different signs and we are expecting to subtract. So 5 minus 3 is 2, and our 2 will be negative since the bigger number has a negative sign, so it will be negative 2b squared. So like terms can be added or subtracted. Then and also like terms can be multiplied. We can multiply like terms. And in terms of multiplying, if we have 3b squared times 5b squared, so we can multiply 3 times 5, we get our 15. Then b squared times b squared, we are going to have b raised to the power 4. So after multiplying like terms, the power increases, of which you can use the principles of indices, where the bases are the same, you add the index. Then also like terms can be divided. So if we have 3b squared over 5b squared, so here we can see that we can just cancel the b. We can just cancel, maybe let's expand, so we have 3 times b times another b over 5 times b times b. So you can see that we can cancel the b's, therefore we are going to have our 3 over 5. So the first point, like terms can be added and can also be subtracted. Then like terms can be multiplied or divided. So if you multiply like terms, we are expecting the power of the variables to increase. While if you divide the like terms, we are expecting the power of the variables to decrease. Now let's look at the unlike terms. Now like terms can be, for some expressions to qualify to be unlike terms, it may be, sometimes they may be same letters, or you may have different letters. Then the other point that you need to just focus is they have different exponent, or they are raised to different power. What we are saying is, if we have y raised to the power 2, another y raised to the power 3, these two are unlike terms, even if they have the same letter, since the powers are different, so they are considered to be the unlike terms. Then the other one, if we have 5b, then 2a, these two are unlike terms, since they have different variables. One has a variable b, the other one has a variable a. So now, in terms of addition, unlike terms cannot be added or subtract. So if I have an example of y raised to the power 2 plus y raised to the power 3, the answer would be y raised to the power 2 plus y raised to the power 3. There I can't add or subtract unlike terms. But for multiplication, unlike terms can be multiplied. So you can multiply like terms. For example, if we have 5a times 5b times 2a, so multiply the first numbers. 5 times 2 is 10, then b times a, which is just ab. So we can multiply the unlike terms. Then for division, we can divide the unlike terms, but we can only divide in terms of if maybe we have y squared divided by y to the power 3. So here we can say y times y over y multiplied by this one. So you can see that on the top we have 2y, so we can cancel 2y's from the numerator and 2y from the denominator, giving us 1 over y. So these are the basics of algebra. Now let's look at some example. So let's say we can simplify each expression as far as possible. So the first one, our a, we have 5x plus 8x. Our b, 3m minus 2m. Our c, 4x plus 3y. Our d, 5a plus 3b minus 2a plus c 4b. So let's look at the first one. So we can see that the operator that we have for the first party is addition. So you can see that here we have x raised to the power 1 and also x raised to the power 1. So you can see that we have the same letters, number 1. Then number 2, they are all raised to the power 1. So they are like terms. And we said like terms can be added. So 5x plus 8x, we get 13x. So you can now pause the video and try to work the other 3 questions. Okay, now let's look at question B. Let's see if they are like terms. Step number 1. So they have the same variable. Okay, number 2, we need to check the power. So this m is raised to the power 1. Also this one is raised to the power 1. So you can see that they are like terms. So we can subtract 3m minus 2m, we get m. Then let's check for C. C, we have the first variable is x, the other variable is y. So you can see that here we are dealing with unlike terms, and we said unlike terms cannot be added. So the answer will still be 4x plus 3y. This cannot be added. Now for the part D here, we are going to do what we collect the like terms. So we need to look at the terms that are like. So we are going to look at, let's look at the first part, 5a. So 5a here, our a is raised to the power 1. Even our negative 2a is raised to the power 1. So you can see that these two are like terms. Then let's check for the other one. So for the other one, our b is raised to the power 1, even our 4b there is raised to the power 1. So we have another like term. So what we are going to do now, we need to group the like terms. So we get our 5a, then its like term is negative 2a plus 3b plus 4b. So 5a, here we have positive plus 5a minus 2a. We are going to subtract. So we have 3a, then 3b plus 4b is 7b. So this is how far we can simplify this question.